Let's do a lab problem from section 3.4. This is problem number 1. The motion of a spring that is subject to a frictional force or damping is often modeled by the product of an exponential function and a sine or cosine function. Suppose the equation of motion of a point on such a spring is this function, s of t, is equal to 3 times e to the negative 8t times sine 2 pi t, where s is measured in centimeters and t is in seconds. They want us to find the velocity after t seconds, and then they want us to graph both the position functions and the velocity functions from 0 to 2. All right, our first step. We want to remind ourselves that when we're looking for the velocity, we are looking for the first derivative. So the original function is s, and the first derivative is s prime of t, and that's what our velocity is going to be. So the function is a product of an exponential function and a sine function, and so we're going to use a product rule to find a derivative. Also, the factors of the products are compositions, so as we're taking the derivative of each one, we're going to look at the chain rule. So let's first take the derivative of the first factor, and we'll throw the 3 in there because it's just a constant. So what's the derivative of this? So the derivative, we'll leave the constant out, and the derivative of e to the anything is e to the anything. But since that anything, or the power of e, is more than just a regular variable, we're going to multiply by the derivative of the power. So this is the power, negative 0.8t, and so the derivative of that is going to be negative 0.8. So that's our first term, or first factor. Now we're going to take the derivative of the second factor, and then we'll put it all together in a product rule at the end. So what we want to do is notice again that this is a composition. We have the outer function is the sine function, and the inner function is 2 pi times t. So the derivative of the outer function is the derivative of sine something is positive cosine something. And then times, we're going to multiply by the derivative of the inside function. So the inside is 2 pi times t, so the derivative of that is just going to be 2 pi. So now that we have that, we can just use the product rule. So it's going to be, so we have to be careful to see what's given to us. The original function is this product. So here we have the first times the derivative of the second, which isn't quite complete yet. So derivative of the second is a cosine 2 pi t times 2 pi. So we'll throw in the 2 pi in there. And then the second function times the derivative of the first. So this is the first, this is part of the first function, and then here in this blank space they want us to find the derivative of the inside. So that's a negative 0.08. Oops, negative 0.8. So that's what we have. And then here, after factoring and simplifying, so let's see what we can factor out. There's a 3 e to the negative 0.08. So we'll put that 3 e to the negative 0.8 t. And then what we have left after that is, if we take the 3 out, or the 3e to that power out, then we will have inside, on the first term, we'll have a 2 pi times cosine 2 pi t. So we have extra parentheses here. I guess it doesn't matter. And then plus, we have this term where we take away the 3e to the negative 0.8t. So that's actually a minus, so let's put a minus sign here. And then 0.8 times the sine of 2 pi t. Looks like I put extra parentheses again. Okay, so that should work, minus the extra parentheses, but I think the answer will still amount to be the same thing. Okay, let's take a look at the graph of the position function. I want us to graph the position function, and if we take a look at the position function, it's this exponential function times a sine function. Now, when t is equal to 0, the exponential function will become 1, and the sine is going to be 0, so this is going to be 0. So first thing to note is that this is going to be the e to the negative 0.8t will kind of envelop the sine function. That is to say that it's going to be within or underneath this graph, and then it's going to be oscillating back and forth. And so, the other aspect of this graph is that it starts with 0. So if we take a look at the graph that starts with 0, there's 2 graphs down here that start with 0, either this one or this one. And the sine function tends to go up first. And so this is a sine function with a positive starting point. So I think it's just going to go up. So let's select this one. So that looks good. And then now they want us to graph the velocity function. So the velocity function is this. Again, this is going to be kind of like the envelope of that. By the way, let's take a quick look at the sine function here, or the position function. So it's going to be 3 times e to the negative 0.8x, or they say t, but we have to use x, and then we have a sine of 2 pi times t. Again, we'll use x, and then here is our graph. So if I want to compare that, just for comparison's sake, to e to the, or 3 times e to the 0.8t, you can see that it actually is like underneath it. And if we really want to do a comparison, this is a more interesting comparison. If we draw the negative of that, then this graph, let's see, let's make it dotted in the same color, and dotted. So the actual graph will fall in between those two functions. Okay, and then that's the original function, the position function. Now they want us to graph the velocity function. So the velocity function, before we actually try to graph it, let's take a look at some of the aspects that's involved. We have again an exponential function that's going to shrink whatever this is going to be as x goes off to infinity, or as t goes off to infinity. This is going to be an oscillating function with a period of 2 pi divided by 2 pi, so that's a period of 1. And then if we put 0 in, e to the 0 power is 1, and sine of 0 is 0, and cosine of 0 is 1. So I'm going to have 3 times 2 pi. Pi is like 3.14, and so this is about 6.28, and then 3 times 6.28, that's about 18 or a little bit over. So my starting point is going to be the positive 18. Before we click on that though, let's take a look at this. Let's make a couple of these things disappear. And then let's actually graph the velocity function. So y equals that exponential function, and then we have 2 pi times the cosine of 2 pi t. Again, we're using x. And then we have -0.8 times the sine of 2 pi t, or x. So if we take a look at this and see where it actually starts, it starts over here at 6 pi, which is what we've determined the starting point, and then it'll go down and do this oscillating like the other function. So let's select the best one. This one goes past 15, the others start close to 0, and this one is negative, so I think it should be this one. Let's check. And we're good. Okay, so hope that helps.